All right, remember on the warm-up we just looked at, we said that the sine of 30, which was 1/2, is the same as the cosine of 60 degrees. And 30 degrees and 60 degrees are complementary angles. All right, so the sine and the cosine are considered cofunctions. And cofunctions of complementary angles are equal. We're going to look at some identities and some trig values that come in very handy. So cofunctions of complementary angles, and I'm going to abbreviate, cofunctions of complementary angles are equal. In other words, the sine of 90 minus theta, if I'm in degrees, if I were in radians, it would be pi over 2 minus theta. The sine of 90 degrees minus theta is equal to the cosine of theta. We saw that. The sine of 90 minus theta equals the cosine of theta. We saw that right up here. Those were equal. Likewise, the cosine of 90 degrees minus theta equals the sine of theta. So if two angles are complementary, their sine and their cosine have the same value. These are cofunctions. Two other cofunctions are the tangent and the cotangent. The tangent of 90 degrees minus theta equals the cotangent of theta, and vice versa. They sound, you hear the co in the names, which helps you to remember that they are cofunctions. The cotangent of 90 degrees minus theta is equal to the tangent of theta. Those two, tangent and cotangent, are cofunctions. And then finally, the secant and the cosecant are cofunctions. The secant of 90 degrees minus theta equals the cosecant of theta, and vice versa. Okay. Now, you need to be familiar. These are considered identities and properties of trig functions. You need to get real familiar with these. We'll be using them off and on the rest of the time that we are working with trig functions, which will be quite a while. All right, we also have some other identities. I'm going to move that out of the way. These are reciprocal identities. And we've talked about these. Sometimes having the identities allows us to rewrite a trig function, which makes it easier to solve. For instance, the sine of theta is equal to 1 over the cosecant of theta. Those are reciprocals. The cosecant of theta is equal to 1 over the sine of theta. Those are reciprocals of each other. And we've talked about that. You just flip the fraction. The cosine of theta is 1 over the secant, and the secant of theta is 1 over the cosine. Now remember, when I listed out the other day the trig functions, I list them out in a certain way. I put the reciprocals right next to each other because it makes it easy to find the values if we have the reciprocals together. And then the last reciprocal values are the tangent and the cotangent. So if you use these a few times, they're not hard to learn. All right, we also have quotient identities. There's two quotient identities. The tangent of theta, when we looked at the unit circle, tangent was what? How did we find the tangent?
Adjacent over opposite, opposite over adjacent.
Okay, if we're looking at unit circle, I heard it somewhere, y over x. But y value, what was associated with the y value on the unit circle?
So,
The sign. So the reciprocal, I'm sorry, let me erase that. We had y over x on the point from the unit circle. But the sign we got from the y value, what did we get from the x value? Cosine. So the quotient identity is that the tangent of theta is equal to sine over cosine. And the other one that we will use is the cotangent of theta. What do you think that might be? If the tangent and cotangents are reciprocals, cosine over sine. We have our Pythagorean identities. He was an intelligent man for sure. Okay, if we think about the a right triangle, and we wanted to say that this is y and this is x, how do we find this side? What do we do? How do we find the unknown side? X squared plus y squared equals whatever. Now in the unit circle, what's the radius of the unit circle? 1. So in the unit circle we have y squared plus x squared equals 1. That's just an equation for a circle with a radius of 1. But what did we say was associated with the y value of the point? What's trig function? The sine. So sine squared x plus cosine squared x equals 1. That is the main Pythagorean identity. If you'll learn that one, you can find the other two. And there are different ways we could look at this one. We could say that if we wanted to solve this for sine squared x is 1 minus cosine squared. Okay, this is the first Pythagorean identity, the one I have the arrow to. But say I wanted to take that and solve it for sine squared, I could. Or if I wanted to solve it for cosine squared, I could. It's 1 minus sine squared. So that's just algebraically working with that equation, sine squared plus cosine squared equals 1. That's the primary Pythagorean identity. And if you'll learn that one, you can find the other two. And we'll do that, first of all, by taking the sine squared plus cosine squared and divide by everything by sine squared. Okay, so my new or sub-identity, sine squared divided by sine squared is 1. Cosine squared divided by sine squared is, we just talked about that identity. X over y is, which trig function? Cotangent squared. And 1 divided by sine squared is the... No, 1 divided by sine squared. Look at your notes you just wrote down. 1 divided by sine squared. Or 1 divided by sine. Cosecant squared.
is it supposed to say 1 divided by sine?
To find the third one, we're going to divide everything by cosine squared. So sine squared divided by cosine squared equals y over x. tangent squared, and cosine squared divided by cosine squared? 1. Anything divided by itself is 1. And 1 divided by cosine squared is?
Cos.
1 divided by cosine squared
Is secant.
secant squared. Because you'll have some like this. Theta is an acute angle, and the sine of theta is 6/10. That's not one we know. I want to find the cosine of theta, and I want to find the tangent of theta using the identities that we just talked about.
So this is all just like function.
Now we're going to look at trig functions, yes.
Oh, dear.
So Carissa, wake up, please. All right, so we know that sine squared plus cosine squared equals 1. So we can use that to find the cosine. And if we have 0.6 squared plus cosine squared, what did you say? I didn't hear you.
Just asked if you could scoot it over, but he
Oh, I'm sorry. Yes, I can. All right, so we get 0.36 plus cosine squared is 1. So cosine squared is 1 minus 0.36. So the cosine of theta, it's an acute angle, so it's going to be first quadrant. I'm only worried about positive. The cosine of theta is square root of 0.64, which is 0.8. The cosine is 8/10.
Wait, how did it end up?
Tangent of theta is sine over cosine. And the sine was 6/10. The cosine was 8/10. We can move both of these decimals over, and 6/8 reduces to 3/4. So the tangent of theta is 3/4. Let's let theta be an acute angle. That tells us we're in quadrant 1. Everything's positive in quadrant 1. And the tangent of theta is equal to 3. I want to find the cotangent, and I want to find the secant. Okay. Cotangent should be easy. If the tangent of theta is 3, what's the cotangent? 1/3. They are reciprocals of each other, so that one's easy. In order to find the secant, we can use the Pythagorean identity that we developed that says the tangent squared theta plus 1 equals the secant squared. And tangent is 3, so the tangent squared is 9. So the secant squared is 10.
go a little bit slower.
Okay. And if the secant squared is 10, what is the secant? It's just square root of 10. Simplify. I want to work on the left-hand side and make it look like the right-hand side. So what do I do when I have two things I multiply together? FOIL. And this is easy because it's the difference of squares.
So we have
1 minus sine squared.
Oh no, Miss Cobra. Miss Cobra, we're about to start the weekend.
All right, 1 minus sine squared. Look at your Pythagorean identities.
That,
The what?
Pythagorean identities. Do you see anything that is equal 1 minus sine squared?
no.
Cosine.
Cosine squared. So we just did what it asked us to do. We worked with the right or left side to make it look like the right side, using those identities.
Booyah.
Wait, so 1 minus sine squared equals cosine?
Squared.
Yes. Okay, we're going to look at sine theta over cosine theta. Plus cosine theta over sine theta. And I want to work with that so that I can get cosecant theta times the secant theta.
I'm gonna have to rewatch this thing on YouTube.
Okay, so what do we have to do when we add fractions? Say that louder, Judah. Common denominator, which I'm just going to multiply straight across to get my common denominator. And I think you have seen what we call butterfly.
Oh, no.
Okay, so we're going to have sine theta times sine theta, which is sine squared theta. Okay, it's, if you, let me say this, if you're going to write sine squared, it's better to put the square in between sine and theta. If you do it this way, it looks like theta squared. So if you're going to put it there, you have to use parentheses or put it in between sine and theta. You're going to see it most times, sine squared theta, like that. What is cosine theta plus times cosine theta?
Cosine theta squared.
Cosine squared theta.
Good. And what is sine squared plus cosine squared? Sine squared plus cosine squared is 1.
I was like, one. Joke.
All right, so let's think about this. 1/0, I could separate it since I'm multiplying. What's 1 over the cosine theta?
Oh, that's CSC.
That's 1 over sine theta, but
1 over cosine.
SEC?
Secant.
1 over the cosine is secant.
Yeah.
So we just did what it asked us to do, step by step by step. If we wanted to find the secant of 5 degrees, 40 minutes, and 12 seconds, we want to change it to decimal form. And to do that in your calculator, first of all, because this was in degrees, you'll want to be sure you're in degrees. Your mode is degrees. But if we do 5 plus, now there's 60 minutes in a degree, so we would have 40 over 60 plus, now there's 60 seconds in every minute, but there's 60 minutes in every degree, so this would be 12 over 3,600. All right, 60 minutes in a degree, but in each minute there are 60 seconds. So in seconds we've got 3,600 in the denominator.
Wait, why are you adding the?
You're doing 60.
Because we want to convert it to a decimal so we can find the secant. Your calculator has minutes, but it doesn't have seconds. So if you plug this in your calculator, 5 plus 40 over 60 plus 12 over 3,600, what do you get?
5.67.
Okay, now, if we're going to find the secant of 5.67, the secant is the reciprocal of which trig function? Cosine. So it's 1 over the cosine of 5.67. That's what you're going to put in your calculator. 1 over the cosine of 5.67.
What are we trying to find here?
Be sure you're in degrees. We want the secant, but you don't have a secant button on your calculator. So we have to use the reciprocal function. So 1 over the cosine of 5.67, be sure you're in degrees, because this is degrees. What'd you get, Judah? No. Did you do it, Sydney?
I got something.
I think we should get 1.0049.
I got 1.22.
You got 1.0049? Okay. I want the cosecant of 34 degrees, 30 minutes, and 36 seconds. Okay, so to get the decimal, you're going to have 34 plus 30 over 60 plus. Good.
You are awesome.
Shh. Okay, so whatever you get there, I don't have that one written down. What is that decimal? We know it's going to be 34 something. 34.51. So what are you going to plug into your calculator?
1 over, no.
1 over the sine of 34.51. And you get, when you plug that in, what'd you get, Anna Grace?
1.765.
The sucks really going up.
1.765.
Okay, so that's equal to 1.765.